M60A1 and continued development of the M51 Missile Guidance System, M51MGS. These were later standardized as the M60A2. Initial plans called to retrofit the turret of every M60 with the new A2 turret, and use them in the mobile anti-armor role alongside the M60A1 tanks. But the continual technical and reliability difficulties with the dual-purpose gun caused this to be abandoned. The M60A1E3 variant was a prototype mounting the M68 105mm rifled gun to the turret of the M60A1E2. This was evaluated due to several earlier faults noted in the M60A1E1's main gun. Compared to the Shillelagh system, the use of the 105mm gun increased the overall tank weight by about 1,700 pounds, 770 kilograms. The M60A1E4 was a conceptual variant that explored the use of various remote-controlled weapons, including a 20mm gun as secondary armament. A mock-up of this design using the Type C turret was constructed. All variants of this series underwent evaluations and trials at the Aberdeen Proving Ground. The M60A1E2 was finally accepted by the Army in 1970 and given the designation Tank Combat Full-Tracked 152mm Gun Forward/Launcher, M60A2. Initial orders were submitted by the Army in 1971, however production did not start until 1973 and continued until 1975. All were built at the Chrysler Tank Plant in Warren, Michigan, with a total of 540 M60A2s produced. The M60A2 was intended to serve as the stopgap solution until its projected replacement, the MBT-70, completed its development. The M60A2 was deployed to Army units in Europe starting in June 1975 when B Company, 1-32 Armour Battalion received its first M60A2 tanks. Features: the M60A2 featured a unique low-profile turret, mounting the M162 gun forward/launcher that drastically reduced the turret's frontal arc in comparison to the A1S. It consisted of a large disc with a narrow channel in the center, with each crew member in the turret having their own hatch. The gunner and loader were located to the right and left of the gun, respectively, and the commander was in a turret basket up and behind the main gun. As a result, each crew member was effectively isolated from one another, with the gunner and loader separated by Shillelagh missiles in their storage position. The commander was in the rear compartment under a large redesigned cupola, which somewhat negated the low-profile silhouette of the turret. The M162 gun was fully stabilized in both turret traverse and gun elevation using the same upgrade kit as the M60A1AOS, allowing the gunner to effectively scan the battlefield while the tank was in motion. This system could be used by the gunner to engage targets with unguided M409 rounds while the vehicle was in motion, but the tank had to remain stationary when firing and tracking an MGM-51 missile. 4 M226 smoke grenade launchers were mounted on each side of the turret bustle. Additionally, there was a mounting point on the left side of the turret for an N/VSS-1, V1 infrared spotlight and M19E1 IR periscope, providing first-generation night vision for night operations. A basket was fitted to the rear of the turret to stow the spotlight when not in use. Late production versions replaced the bore evacuator with the closed-bore scavenger system, CBSS, a compressed air system that pushed the fumes and gases out of the muzzle when the breech was opened. Initial production M60A2s used the M60A1 hull powered by a Navy DS-1790-2 Atlak engine, CD850-5 cross-drive transmission and the T97 track assembly. Many of these hulls were later upgraded to the RISE standard. The M51 Missile Guidance System, MGS, for the Shillelagh missiles was designed by Ford's Aerospace Division. The M51 MGS consisted of an infrared, IR, direct beam guidance and control system to track the missile mounted to the turret over the mantle of the gun with a telescopic sight and a Raytheon and forward/WG1 flash lamp pumped, ruby laser range finder, accurate to 4,000 meters, for the gunner. The gunner aimed the crosshairs in his direct telescopic sight at the target and fired the missile. After acquiring a target, a small charge would propel the missile out of the barrel. The missile's solid-fueled sustainer rocket then ignited and launched the Shillelagh. For the time of flight of the missile, the gunner had to keep the crosshairs pointed at the target. A direct infrared beam missile tracker in the gunner's sight detected any deviation of the flight path from the line of sight to the target, and transmitted corrective commands to the missile via an infrared command link. The MGM-51 was stabilized by flip-out fins, and controlled by hot gas jet reaction controls. The gunner also employed an M219, later replaced with a M240C, to the gun mantle's right with 2,000 rounds. The commander's cupola was redesigned, causing the M85 to be mounted in the inverted position in order to provide access to its feed cover, and mounted a single M34 periscope carrying 600 rounds. The M60A2's combat load for the M162 main gun consisted of 33 M409 rounds and 13 MGM-51 Shillelagh missiles. Flaws. This weapon system had several drawbacks. First, the gunner had to keep the target in the crosshairs of the sight during the entire flight time of the missile. This meant that only one target could be tracked and engaged at a time. Furthermore, the M60A2 could not fire or track a missile while moving. Secondly was the high minimum range of about 730 m, 2,400 feet. Until the missile reached this range, it flew beneath the tracking system's infrared beam and could therefore not be guided by the infrared command link. Also, minimum range was slightly above the maximum effective range of the M60A2's conventional unguided munition. This created a dangerous gap area that could not be adequately covered by fire, known as a dead zone. It was also discovered that structural cracks in the barrel occurred after several missile firings. This defect was traced to a flaw in the missile's longitudinal key, which fitted into a keyway inside the gun barrel. It was determined that a less deep key would significantly extend the service life of the barrel. The missile control system was also very fragile owing to its dependence on vacuum tubes, which often broke when firing the gun. Finally, a Shillelagh missile was considerably more expensive than the M409 round. The vehicle was one of the most technologically complex of its era, eventually garnering an unofficial nickname of Starship. This also contributed to its failure, largely due to difficulties with maintenance, training, and complicated operation. The M60A2 proved a disappointment, though its technical advancements would pave the way for future tanks. Its intended successor, the MBT-70, was cancelled in 1971 and its funding diverted into the conceptual development of the XM-1 Abrams. The Shillelagh /M60A2 system was phased out from active units by 1981, and the turrets scrapped. The main replacement for the Shillelagh missile in the mobile anti-armor role was the more versatile BGM-71 TOW. Most of the M60A2 tanks were rebuilt as M60A3s, or the hulls converted to Armored Vehicle Launched Bridge, AVLB, vehicles, and M728 combat engineer vehicles, with a few M60A2s retained as museum pieces. M60A3 series, edit. Development. Due to the rapidly developing advancements in anti-armor capabilities and solid-state electronics of the 1970s, along with the general dissatisfaction of the M60A2, an upgrade of the M60A1 was needed. In 1976 work began on the M60A3 variant, which featured a number of technological enhancements. Features: the M60A3 version of the M60 series had the same mobility, performance, and weapons systems as the M60A1 Rise and Rise passive tanks and incorporated all of their engineering upgrades, improvements and capabilities. The electronics and fire control systems were greatly improved. The turret's hydraulic fluid was replaced with a non-flammable one. This updated turret configuration was mated to the M60A1 Rise hull using the AVDS 1790-2D Rise engine and CD850-6A transmission along with a Halen fire suppression system. It was designated as the Tank Combat Full-Tracked 105mm gun, M60A3. The M60A3 tank was built in two configurations. The earlier version, sometimes referred to as the M60A3 Passive, uses the same passive gunner's sight as the A1 Rise Passive, and the latest version has a tank thermal sight, TTS. The M60A1, Rise, and Rise passive tanks used a coincidence rangefinder and the mechanical M19 ballistic computer. The M60A3 uses a laser-based rangefinder and the solid-state M21 ballistic computer. The M21 FCS for the M60A3 was made up of a Radian and /WG2 flash lamp pumped through the laser-based rangefinder, accurate up to 5,000 meters for both the commander and gunner, a solid-state M21E1 gun data computer incorporating a muzzle reference sensor and crosswind sensor, ammunition selection, range correction and super elevation correction were input by the gunner, an improved turret stabilization system along with an upgraded turret electrical system and solid-state analog data card bus. The M10A2E3 ballistic drive is an electromechanical unit. The commander had an M36E1 passive periscope and the gunner an M32E1 passive sight. The TTS configuration replaced the gunner's sight with the Radian and /VSG2 tank thermal sight, TTS, a mercury-cadmium telluride, HGCD IR detector. This sight allows the gunner to see through fog, smoke and under starlight conditions without the aid of an IR searchlight. This system provided improved night fighting capabilities. The first M60A3s were assembled at the Detroit Arsenal Tank Plant in February 1978, where the first of a low rate of initial production quantity of 296 M60A3s were produced through October, with fielding to Army units in Europe starting in May 1979. The M60A3 was seen by the U.S. Army as a stopgap measure as the development of the XM1 Abrams MBT was already well advanced, with fielding to Europe planned to start in 1981 and notified Foreign Military Sales (FMS) customers of its near-term plans to discontinue M60 series tank production. In March 1982, General Dynamics Land Systems purchased Chrysler Defense. The procurement of M60A3 and M60A3 TTS tanks for the Army ended in June 1983 with the purchase of 120 M60A3 TTS tanks, while production of the M60A3 for Saudi Arabia and M60A3 hulls for Taiwan was expected to end in May 1985 after over 15,000 M60s were built in total. But in May 1985, Egypt placed an order for 94 M60A3 tanks at the cost of US $165 million. In 1986, the Egyptian order was complete. The Army also increased its M60A3 TTS fleet through the M60A1 Product Improvement Program, PIP, and the M60A3 Tank Field Retrofit Program conducted by the Anniston Army Depot and the Mains Army Depot, MZD. Depot field teams retrofitted all of the Army's 748 M60A3 tanks to the TTS configuration by the end of 1984. In addition, both depots converted a total of 1,391 M60A1 Rise tanks to the M60A3 TTS standard in that same year. In 1989, the U.S. Army had a total of 5,400 M60A3 TTS, of which 1,686 were newly built tanks. 114 were M60A1 passive tanks retrofitted to the M60A3 TTS standard, and 3,600 were conversions made by the Anniston Army Depot and Mains Army Depot. These M60A1 Rise PIP conversion programs were concluded in 1990s. Italy, Austria, Greece, Morocco, Taiwan, and other countries upgraded their existing fleets with various E-60B component upgrades under several FMS defense contracts with Raytheon and General Dynamics during the mid to late 1980s. In 1990, M60A3 E-60Bs from Army surpluses were sold to Oman, Bahrain, and Saudi Arabia. The M60A3 replaced the M60A1 in the U.S. Army and any remaining M48A5s in ARNG service on a 1-for-1 basis. The Marine Corps continued to use the M60A1 Rise passive until they were withdrawn from combat use in 1991. They were phased from ARNG service between 1994 and 1997, being replaced with the M1 MBT. The Detroit tank plant was closed in 1996 with production of the M1A1 Abrams continuing at the Lima tank plant in Ohio. E60 series, edit. M60s for use in foreign military service were designated as the E60 series by the U.S. Foreign Military Sales, FMS. These were essentially M60s with minor modifications requested by approved foreign purchasers. Some of the modifications included removal of the M19 cupola, different models of machine guns, electronics, fire control systems or radios, external armor plates, smoke launchers and power packs. Israel purchased many of these tanks, forming the basis for the Magak 6 series. This series included the following designations. 1 E60, modified M60 variant for non-US service. 2 E60A, modified M60A1 variant for non-US service. 3 E60B, modified M60A3 variant for non-US service. The M60A2 was never approved for foreign sales. Army National Guard evaluations, edit. M60AX, edit. Priority in initial M1 Abrams unit allotments was given to active Army armored units in Europe. The Army National Guard's armored assets were key strategic elements, approximated at 3,000 tanks, and were important for reinforcing active Army units in Europe in case of conflict. Without an inventory available to provide the ARNG with M1 Abrams tanks, unfunded requests for proposals, RFPs, were circulated by the ARNG Tracked Vehicle Task Force starting in 1983. Teledyne Continental developed the first RFP upgrades to the suspension, power pack and transmission. It was demonstrated and tested at Fort Knox in January 1985. The upgrade was not evaluated for U.S. military service or assigned a designation. GDLS acquired Teledyne and by 1987 had pursued the RFP improvement to the armor, mounted the M60A1, and called it the Super 60. It was the reference point for the ARNG upgrade decisions submitted to the Department of the Army to upgrade its M60 A3 TTS fleet. In the actual report, the upgrade is referred to as the M60AX. $90 million was requested for prototyping and $2.8 billion to complete the fleet conversion by fiscal year 1989. M60 A4, edit. The M60 A4 was the proposed upgrade of the M60 A3 TTS for the National Guard that emerged from the M60AX study conducted by the ARNG Tracked Vehicle Task Force with a projected cost of $750,000 per tank. The upgrade would have included improved protection, automotive performance and combat effectiveness, but retained the same M60-81 gun as the M60 A3. Since the M60AX evaluation vehicle was not in the U.S. Army logistical system, the requested components for the upgrade were inferred to by FSCM part numbers. After examining more than 24 possible upgrade components for the M60 A3 TTS, the task force decided on the 15 subsystem upgrades that made up the M60 A4 overhaul. Survivability upgrades included both applique and wraparound armor, internal spall liners, laser protection, an automatic fire suppression system, an engine smoke generation kit and a new low-profile cupola. Mobility enhancements included a new 1,050 horsepower engine, a new automatic transmission, improved final drives, an improved vehicle suspension and a modification to the air cleaner. The M60 A4's key target acquisition and fighting improvements were an upgraded laser rangefinder, an enhancement of TTS optical performance, a modified fire control system and an improved turret drive and stabilization system. After reviewing the proposal, it was declined by the Chief of Staff of the United States Army General Carl E. Vuano in 1988. No prototype was ever constructed. The U.S. Army did not view the M60 A4 as a cost-effective proposition for the National Guard, with only a limited increase in crew survivability and the same firepower as the M60 A3. The M60 tank was superseded in ARNG service by the M1 version of the Abrams tank beginning in 1990. The M60 A3 was phased out from ARNG service and was fully replaced by the M1 A1 by 1997. Most of the M1 Abrams tanks were upgraded to the M1 A1 configuration. Foreign upgrades, edit. A U.S. congressional report in November 1993 stated that there were 5,522 serviceable M60 A1 and M60 A3 tanks in the U.S. Army's inventory available for sale or transfer to U.S. allies or foreign nations. Of these, 111 were in Korea, 1,435 were in Europe, and 3,976 located in CONUS. The average age of these tanks was 16 years and an expected peacetime service life of 20 years. The average price was US $212,898 per tank as is, without radios or machine guns, and they were not mechanically overhauled. Tanks located in Korea were inspected and sold to Bahrain and Taiwan. Of the 1,435 tanks in Europe, 1,311 have been cascaded to other NATO countries under the terms of the Conventional Forces Europe Agreement, CFE, 18 reserved for non-combat use and 106 returned to CONUS. Egypt inspected 411 tanks at Fort Hood and 91 at Fort Knox and tentatively selected 299 of those. An additional inventory of tanks from the CONUS M60 fleet were available at the same unit price for other approved purchases. The United States chose not to pursue further upgrades to the M60 tank series after 1978. Its near-term replacement by the Army with the M1 MBT was scheduled to start production in 1980. M60 series tanks were phased out of U.S. service by 1997 and opposing force, OP4, training use in 2005. Together with the large number of M60 MBTs still in foreign service and a large U.S. Army surplus inventory, several upgrades for the tank were offered starting in 1985. There are three basic approaches to upgrade decisions for the M60 MBT. Some countries, such as Taiwan and Jordan, have sought to modernize the M60 as a frontline MBT. Turkey is seeking a middle ground, keeping it useful as it develops more modern designs. Other countries, such as Egypt, Saudi Arabia and Thailand are modernizing their M60 fleets for counter-insurgency type operations. While the market for M60 modernization is somewhat limited, because the tank is generally operated by poorer countries or has been relegated to secondary tasks, other companies have come up with more advanced Service Life Extension Program, SLIP, upgrade solutions. Additionally, several countries also funded their own design upgrades. Notable examples are the Magak, Sabra and Phoenix variants. In 2005, M60 variants were in service with Egypt, Greece, Israel, Jordan, Turkey, Taiwan, and some 20 other nations to varying degrees. High-performance forward/Super M60 main battle tank, edit. The high-performance M60, also called Super M60, was a comprehensive update package for the M60 A1 and A3 tanks, first demonstrated and tested in 1985 by Teledyne Continental. The vehicle was developed as a private venture for the export market and was never evaluated for U.S. military service. Unofficially called the M60AX, the upgrade offered to increase the protection, firepower and mobility for the M60 A1 and A3 tanks. The Super M60 prototype was based on an M60 A1 leased from the U.S. Army. It featured the AVCR 1790-1B engine producing 1,200 HP, 890 kilowatts, coupled to a Rencar K304 transmission with 4 forward and 4 reverse gears. The torsion bar suspension system of the M60 was replaced with a high-drop pneumatic suspension system, HSS, developed by the National Waterlift Company as seen on the Himag, General Motors XM1, and the Jordanian Centurion, Tariq. Over the M60 A1, the Super M60's top speed increased to 45 miles per hour, 72 kilometers per hour, and power forward/weight ratio increased to 23.1 HP forward/T, 17.2 kilowatt forward/T, despite the 9,500 pound, 4,300 kilograms, increase in weight. This high-performance configuration was demonstrated and tested at Fort Knox in January 1985 but was not designated. Although the U.S. Army chose not to adopt the installation of a new power pack or suspension.
Good. The housing did not crash. It's 9:20. When I pause the reading, it's sometimes crashing. It did not do that because they are so long. I need to do it like 3 hours. This one is so long. I need to read it 2 times, so I need to charging my camcorder. The sun is shining, so it will be super hot today.